last class, we discussed how to dismantle the motor, record winding data, prepare and provide the slot insulation, and prepare coil winding and forming. In continuation to this, in this video, we are going to learn how to insert the coils in the slot, record winding data and strip the winding, prepare slot insulation, prepare the stepped former and coils, lay the coils in the slots and test the windings. Task 4. Insert the coils in the slots in proper sequence. First, insert the left coil sides of first coil, second coil and third coil in slot 1, 3 and 5 respectively. Insert the right coil side of the first coil in slot number 6. Insert the left coil side of coil 4 in slot 7 and then insert the right coil side of coil 2 in slot 8. Insert left coil side of coil 5 in slot 9 and then insert the right coil side of coil 3 in slot 10. Proceed likewise till you are left with the right coil sides of coils 11 and 12. Insert the 11th coil right coil side in slot 2 and then the 12th coil right coil side in slot 4. Insert the wedges in the slots so that the coil sides are well packed in the slots. Insert the half moon shaped face insulation paper between each coil in both sides of the overhang. Follow the developed diagram and connect the end, group and terminal connections. Tie the connections with overhangs and shape the overhang. Test the winding. Measure the resistance between A1, A2, B1, B2 and C1, C2 and record the values in tabulation. Resistance between A1 to A2, resistance between B1 to B2, resistance between C1 to C2. All the three resistance should be equal. Measure the insulation resistance between the windings and the stator core with 500 volt meter and record it in tabulation. Insulation resistance between core and A phase, between core and B phase, between core and C phase. Measure the insulation resistance between the windings with the 500 volt meter and record it in tabulation. The above values should not be less than 1 megohm in any case. Insulation resistance between A phase and B phase, between B phase and C phase, between C phase and A phase. Varnish the winding. Assemble the motor and test run the motor with load for 8 hours. Task 5. Record winding data and strip the winding. Collect the nameplate data and record in tabulation. Induction motor. Make, phase, volts, frame number, kilovolt per HP, amperes, model, RPM, frequency. From the nameplate details, calculate the number of poles and write it below. Number of poles. Dismantle the given motor, Record the details of the existing winding details before and after removing the coils from the stator in tabulation. Identify the windings of the given motor, whether it is single layer concentric winding. Record the number of slots, number of coils, and the pitch of the coils in tabulation. Number of slots, number of coils, coil pitch, number of poles, number of coils or slot, end connection, half coil or whole coil. Trace the group or let connections and draw the same for reference in the space given. Record the length of the overhang projection and prepare a template which could be used to check the overhangs after rewinding. Remove the wedges from the slots. Strip all the coils out from the stator except one complete group of coils. Use a thinner in the winding and remove carefully one complete group of coils without damage. Check the total coil weight and record it in tabulation. Number of circuits, turns or coil, size of the wire multiple, total weight of scrapped coils, wire insulation. Clean the stator slots using the complete set of coils. Measure the S size and shape of the coils and record the details in tabulation. Shape of the coil, diamond or rectangular or oval. Outer coil, coil length, coil width, coil thickness. Prepare the slot liners and insulate the slots. Task 6. Prepare stepped former and coils. Select a suitable sized former according to the dimensions recorded in tabulation. Outer coil, inner coil, coil length, coil width, coil thickness. Set the adjustable stepped former to the dimensions of the coils taken as data from tabulation. Wind the designated number of turns in each coil of the group by referring to tabulation. Leave about 150 mm in the starting end of the coil for connection. Number of circuits, wire multiple, turns or coils, weight of scrap, size of the wire insulation. Tie the turns of the coil tightly with twine thread or either side of the coil after winding. Cut the remaining length of wire, leaving 150 mm extension. Remove the coil from the former without damage. Wind one set of coils of the group for trial and verify the size with stripped out coils. Preferably, insert one set of groups of coils in the assigned slots in the stator and check the correctness with respect to overhand, etc. Find the required number of coil groups similarly. Shape the coils by folding the ends in the straight part of the coils. Task 8. Lay coils in the slots. The procedure for 24 slots, 12 coils, 4 poles, single layer concentric winding, half coil is shown in the scene. You can adopt the same procedure for the other stators of different slots and poles with necessary modifications. Insert the guide papers in the groups of slot number 2 where the windings will begin. In the concentric type of winding, the insertion of coils should start from the inner coil, which is having the shortest pitch. Check the connection side of the winding with respect to the stator and hold the connection end of the coil in that side. Place a leatheroid paper of length equal to the width of the core in the right side of the core. To avoid insulation damage to the winding wires, check at intervals the position of the leatheroid paper which is kept on the core between the right coil side and the core. Separate the inner coil from the group. Hold the smaller coil in hand and keep the larger coil in front of the stator in a leatheroid paper tray. Insert the left coil side of the smaller coil in slot number 2. Remove the guide papers and insert them in slot number 7. Insert the right coil side of the smaller coil in slot number 7. Remove the guide papers from slot number 7 and insert them in slot number 1. Insert the left coil side of the larger coil in slot number 1. Remove the guide papers and insert in slot number 8, and then insert the right coil side of the larger coil in slot number 8. See to it that the current direction in the group is correct according to the developed diagram. Insert the second coil group having smaller and larger coils in slot number 6, 11, 5 and 12 respectively. Insert likewise third, fourth, fifth and sixth coil groups in the respective slots. Refer to the developed diagram. Insert a separate paper in all the slots over the inserted coils. Fold the slot liner and insert the wedge in all the slots. Insert a half moon-shaped insulation paper as face insulator between the coils on either side of the overhang. Task 9. Connect all the coil groups. Connect the group connection of the same face and solder them according to the end connection and developed diagrams. Sleeve the joints. Connect the face sleeve with coil groups and insert the sleeve over the joints. Use a nylon mallet and shape the overhang of the original size. Check the size of the overhang with the help of overhang template. Tie the hemp thread to bind the soldered joints along with the overhang. Task 10. Test the winding. Test the winding by measure continuity, short and insulation resistance test and note down results. Task 11. Varnish the windings. Dry the moisture by using lamp loads. Check the varnish dry level. Task 12. Test and assemble the motor. Test and run the motor to ascertain its performance. In this video tutorial, we have discussed how to insert the coils in the slot in proper sequence, record winding data and stripe the winding, prepare a steeped core, lay coils, assemble and test the motor. Thank you for watching. Have a good day.